part and the chapter. Read the book and the slide. Okay? These are the two things. These are the two things that you must do if you are really serious about it. Because once you have done it and you fail to understand some important issues, you can quickly send me an email for quick clarification. All right? This is the part of the preparation. You shouldn't avoid the book. Don't ignore the book. That's my first and foremost advice. On top of that, on top of that, I have shared a YouTube channel NMS. I keep adding simple videos from YouTube explaining some relevant topics. Check those things out. Whenever there's not too many videos there, but some issues. And that is not restricted. It's just when I find them, I add them to the channels. You can explore on your own and learn about the particular topic from any other external resource that you can access. Okay? That is for your preparation, a comprehensive preparation. Now, that is from a learner's point of view. Now, if you are interested to know, and of course, all of you are interested, at the end of the day, you need to pass the exam, right? To pass the course. That's where it all comes down to. If you want to pass the course, then the first things, the things that you will have to do, there will be 5 labs. I will talk about labs in more details. There will be labs. There will be quizzes. There will be a presentation. That's all. Number of labs, 6, which will be implemented as 4 plus 1. 6 will be implemented as 4 plus 1. In other words, all labs I will talk about labs later in more details. You have to do it on your own. And one revision quiz that will represent labs 5 and 6. That will be in the last week. Last weeks. That's it. That's all about labs. There will be 2 quizzes and one presentation. The distribution of grading for your final score calculation is 20% from labs, 20% quizzes, 20% presentation, 20%, and final exam, 40%. Talking about this, I just remember, I'm going to check it right here. As you can see on my screen, I've got all those things right here. I will log in. I will share the syllabus with you. Wait a minute. You see the internet is already started wobbling up a little bit. That's why I turned off my camera. It is slow. What is happening? This site can't be reached. Some problem, technical problem, server problem. Well, whatever, don't worry. This is what we're going to do, and I will share this syllabus on LMS. Okay, did you get your answer? Any more question? Any other questions?
Can I have your YouTube channel?
You will. It's already on the LMS. So now talking about LMS, the first thing that you have to do is to enroll yourself in this course. As you can see on your screen, OSG202 Shenbi. Now to do that, you know how to self-enroll. You go there, and I've created a group for you. Okay, I'll show you right here because we are presenting, so you can get a hint of that. Wait a minute, users, enroll users, groups. As you can see, there you are. No one enrolled yet. That's your group. And your enrollment key or password is your group ID. So that means it will be this. So go there, enroll yourself. Okay. It could be. Yeah, I think so. I think so. That is it. But you don't have to access it externally. You join the LMS. This is your enrollment key. Okay. As you enroll yourself to this group, you will see the YouTube channel at the bottom. YouTube channel, as you can see on my screen. Okay, YouTube channel, you just click there and you will go there. All right. Any other question? I will continue to add as I find, as sometimes I spend my time. And is our class 604 or 603? Well, you was a 603 when I created it. Oh, wait a minute, wait a minute. They keep changing your schedules. I mean, wait. Gosh. I mean, I created those links, those groups, at least a week ago. At that time, it was AOT. I don't know whether they, in the meantime, they changed. Let me see. What happened? My fab isn't working. It was AO3. Now I can't access it. The server is unavailable. So what do you think? Is it AO3 or AO4? Did they change it last minute? Because I remember they gave me the AO3 class. I mean, 1603 class. Did they change at the last moment? Can any of you just confirm? Oh, now it is 1604. All right. So I count new and I change it right here. One 1604. So let me edit it right here. Users. Okay, your password is still the same. I'm not going to change the password, but just to avoid confusion, I'm just going to change it to 604, as you said. Is that okay? Password is still the same. Please choose another one. No, it doesn't take. Oh, there's some. Wait a minute. So your group is AI 1604. If your group, or I have both of them, AI 1604, then yeah, your one is AI 1604. That is the enrollment key. All right. And I'm going to unenroll the others from AO3. So you guys, all you guys, you join right here. Okay. It's very important. It's very important that you enroll yourself in the right group. Very important. Otherwise, things will get messed up towards the end. Your grades will get lost. So just be careful about these little things. Okay, now that you have gotten into your course page, you can see the LMS and see all kinds of things right there. I will share the syllabus when it is available. It's the moment. You can see the server is not responding. You have the chapters from 1 to 4 you can download. And you have the YouTube channel, you have the presentation grades, not important. A little bit of details about the presentation. That will be usually in week 10 and week 9. So hopefully by that time we can go back to our university, to our classroom. Labs 1 and 4, I will talk about it in details. There were 2 quizzes, one in week 4, and the one in week 8, probably. Depends. It will cover, these 2 quizzes will cover a bunch of chapters. Now, talking about the chapters are right in front of you. Okay? So any other technical administrative issues, if you have, you just let me know. Any question related to technical issues? All right. If you don't have, then let me talk a little bit about the course that we are going to take and the chapters that you will have to cover from the book. The first thing are the chapters. There will be 6 chapters. In the book, there are 10 chapters, but we are not going to study 10 chapters. Out of these 10 chapters, we will study 6 chapters, starting with introduction, then process and threads, then memory management, then I/O, input output, file systems, and finally deadlock. These are the chapters that we will study, and the lectures that I will give you will be based on these six chapters. And these are the chapters from where you will get questions in your final exam. Okay? There won't be any other question from any other chapter. Now, when it comes to presentation, and as you may have seen, those who have already enrolled to LMS, you have read those instructions in the presentation part. It's clearly mentioned when you give the presentation, it needs to be from one of those chapters, chapter presentation, chapters, topic from 7, 8, 9. Chapter 7, 8, 9, a relevant topic. You don't have to cover everything, but it's a relevant topic on chapter 7, 8, 9. We'll talk about it in more details later when the time comes. It's still a long way to go. Now, this chapter 7, 8, 9, these three chapters are out of the scope of your final exam. That means there won't be any question from these chapters in your final exam. Rest assured about that. These are called self-study chapters, and that's why we will ask you to give a presentation relevant topic from one of these three chapters. Is that clear? Any question here? If you have any question, let me know. If you don't have question, then what are the other things that we need to know before getting started? Labs. I'd like to open the labs right at the beginning. So I said that there will be, for all these assignments, there will be a deadline. And my request to all of you is always stick to the deadline. That helps me, that will eventually help you. Because for the labs, as I said, the labs that you'll be working on, I will give you more details of the labs, probably not in this class, in the next class. But those will be pretty easy. The first part is about installation of a couple of software. You can do it. If you have any problem, try it again. If you still can't install it, ask your friends to help you. Even then, if you can't do it, then let me know. I can't fix your problem from here, of course. Where like the drift. And if you stick to that problem, if you still have that problem, the persisting problem, then I will give you an alternate suggestion. So how to carry on with your labs. No issues. Take it easy. That is what labs are all about. And as I said, these labs will not help you to write your own software, but these labs will be quite handy for you to do a little bit of experimentation, or rather say interaction, direct interaction with the underlying OS, which is sort of intangible for all of us, for the users. What I mean by intangible is well, we can at least see the application software because every day we start them and we know how it works. We have beautiful graphic interface on this application software. But for OSG, we have no clue what's happening behind the scene, deep inside your computer. So that's why I call it an intangible software, something that can't be touched. Well, anyway, you can't touch software, but straight. Still, this is what you need to do. You need to do a few very simple interactions with the operating systems, pass some commands, and get the responses, record them, and send them back to me. That's it. I'll give you the more details. This is not where I'm going to give you the details. I'm just giving an overview of what you should be expecting. As I said, it's the first class and absolutely nothing too deep. The quizzes, you are familiar with those quizzes. The quizzes will come, they call it progress test. There will be around 20 questions for 25 minutes. And since we are taking two quizzes, we will cover three chapters, the first three chapters and the second three chapters. Of course, I will let you know that which chapters are covered. And actually, you can see it right there on LMS. Everything is in order. When we get to the end of those three chapters, the first three chapters, then we'll take the first quiz. And we get to the end of the last three chapters, then we'll take the last quiz. Okay? Don't miss the deadlines. Whether it's a quiz, whether it's the lab, you will have plenty of time in advance. I will tell you, I'll give you weeks to finish it, but don't miss the deadline. It is a real mess up. And one thing, I don't receive any email submissions simply because the emails get messed up and lost. I can't keep track of who is sending which group and which student is sending which email. And I have a whole bunch of official emails coming every day. So things will get absolutely messed up. So I don't receive any email submission. Okay, no submission by emails. If you want to ask me questions, you can ask me. No problem. The point is why I'm talking about sticking to the deadline is if you miss the deadline, and sometimes I tell you from my experience, some of you just ignore it. Oh, who cares about a deadline? I'll just leave it. I will do it the last moment before the exam comes. Sorry, I will not receive it. I will not open it. Your lab score will become zero and you will fail in the exam, fail in the course, because you will not be eligible for the final exam. When I get this kind of requests, and I feel really irritated. And it happened last semester. I had to chase them on the last day of the course. I had to chase the students that you didn't, to remind them that you didn't submit your labs. You're going to fail. Now, I'm not going to repeat it again. That's not my responsibility. It's your responsibility. You miss the deadline, you are done. You're gone. Because I can't keep going back and changing the deadlines and opening the link again and again and again for this student, for that student, for those students. That is not the way to do it. So please remember the deadlines. As you can see, those will be highlighted right there at the moment. Nothing set up. When everything is there, but the deadlines will be set up. And I will alert all of you that I've given the deadline. No problem with that. Quizzes you can take at home, no problem, but only one time. can be taken only one time. You've asked me a question. Will you create a group chat on a messenger? What is a group chat on messenger? What exactly you are talking about? Which messenger? You mean Facebook? Facebook group chat, I don't think it is necessary. Maybe some teachers are doing it. Of course, I don't know. I haven't made any group chat like that. But if you want, you can make it. No problem. The problem is for me that in that case, in the group chat, you have to write everything in English. That's for sure. Otherwise, I will not understand. That's why for most of the group chats, I stay out. You can. You can do it. You can also send me message on LMS if you want. No problem. Okay. So in whichever way you find it convenient, do it and collaborate. Definitely you should collaborate and you can just let me know. And as we'll see later, where was it? Right here. This too is not coming. Gosh. It seems the whole server is down. Let me see. Oh no, it's come back. It's a little bit of problem here. Okay, there we go. Mm, 1604. You can also go to the EduNext, and I think you may have also may have some links right here actually. There's an EduNext link. Was it in there? These are the study slides that I have shared. Now the EduNext links are not here, but you have the EduNext links, so you can go to the EduNext and study some questions right there because it's not mandatory at the moment. So I will not be using the EduNext quite often, but you can also, if you want, you can go there and see what they're posting there and stay updated. That would be helpful for you. Coming back to presentation. Presentation, I think you already know about presentation looking at your LMS. It is a group presentation. It used to be a group presentation. If in class, it will be a group one, but if it is online, then it will be individual. Okay. So stay prepared for these presentations, although not the moment presentation. As I've said, I usually take presentation week 9, week 8. First, to get started, your focus should be on labs. And for the labs, you'll be required to download first VMware, then install Fedora shell on it. All instructions are in there. All of these instructions are in the lab files, lab 1. If you go there, click on the link. Where is it? Right here, labs 1 to 4. If you click on the submission, then you can see some files there. Labs.rar. Download this file. There will be 4 files there, and there are instructions. Always install the latest version. And there will be problems in installation. I know it. It happens. But as I said, that we can't really fix it. If it happens, then try to uninstall and reinstall. If you still fail, nothing to worry. Let me know. We will find an alternative. Okay. Always install the latest version. Any other question you have? Any of you have any other question? Okay, if you don't have any questions, then let me tell you what you should expect from this course in the classes. At certain points, you may find that it is too heavy on knowledge. That could be a little bit boring as well. Well, it is. Everyone knows that it's a theory-based class. But if, as I suggested earlier, if you take notes and if you follow the lectures along with the text from the book and the slides, then you can build up your own set of knowledge about operating systems. The things that we'll be studying right here, I will use the slides. I have, as you can see right here, I've used both my old slides and the new slides. I'll be following, for teaching purpose, I will be following the old slides because they are more organized. The slides, the old slides. I will be using my slides actually. The my slides that I'll be teaching, you will, those slides will not match either study slides old or study slides new. But don't be confused because e- every little thing that you will see on my slides have been taken, literally copy pasted, including the grammatical and spelling mistakes. I didn't edit anything. I simply copy pasted them from these slides, and mostly from the older version of the study slides. Okay, the same things are there in the new study slides as well. The reason I made it was because those were the teaching slides, and everything comes from the study slides. So I'm not going to share that particular slide because that is more like a synopsis. And you, as a student, when you study, you're supposed to study in more details. So you should study from those slides, and I guarantee every little thing that you see on my slides, you will find them right there on those slides. If you don't find it there, just let me know. Okay. The reason we do it in that way, the way we do it in that way is to be to give you an overview of the overview of the certain parts of operating system that we'll be discussing. For example, when we want to talk about process and threads, the purpose of teaching is to make you understand in a holistic way that what these things are and how do they really, in real time, how do they play out. So there is a connection, as you can see, from one point and one chapter, between one chapter and another chapter, one part and another part. Because everything is happening inside that so-called operating system, the system software. The purpose of teaching, the purpose of the lecture is to help you develop, help you develop that wonderful holistic view of something called operating system that takes care of every little possible things here and there. And that's why this course has operating system general. And it's a general purpose course to give all the students, irrespective of whether they, whatever their majors are. I had students before from graphic design. They were learning operating system in my class. So, and of course, software engineering. You guys are from artificial intelligence. So all these students should know that what operating system is and what operating system is comprised of and what it does and why we need it. Some of the bare essentials, some basic need to know about all these things is because at the end of the day, you will have to do whatever you do, whether related to artificial intelligence or software development or graphic design, you will have to use this machine. That is your computer. And your computer, as you all know, will become an absolute useless junk of hardware if you take the operating system out from it. If you take the operating system out, your computer literally is dead. So we need to understand the very fundamentals of the operating systems, the way it works, the things it takes care of, and the tasks that it performs. All right? So that is what we will be studying. We'll be talking about processes and threads. In a very light-hearted way, I can get started. I can ask you, when you think about processes and threads in any one, tell me what you think when you hear the word process. Now, we will start with some very basic questions. Like, what could be the difference between a process and a program? We talk about these two words. We use these two words often interchangeably, program and process. Can anyone give me a heads up? Are the same? Yes, sure, sure. You don't have to raise your hand. Just raise your voice. Feel free. All right.
I think the primary difference is process is a running program.
Hmm.
Is it? I think it's the main difference.
Oh, microphone down. Could you repeat it once more, please?
Just want to say the main difference between a program and a process is that a process is just a running program. Is it?
You, you are absolutely right. A
Okay.
running program. Okay. So when you say running program, may I ask you, so what is a program then? What is a program? And what do you mean by a running program? I'm going
I think
to, yeah, yes.
yeah, I think a program is just something programmed by the programmer. It could be a software or something like that.
Mm.
And when we run that program, it means that we make it to operate.
Okay. So what you mean by running that software?
Running the software means that we we force it to operate as we want it.
Okay. As it's perfect. I accept it, no problem. But when you put it in a little bit more technical way, this is where we'll be learning. This is a good base because I want all of you to literally build up your knowledge based on what you already know. So you already know the right answer, and that is what we all, most of us, we know that it is a running program. But before you use the word running, there are some kind of issues there because a program is basically a stored file. A stored file. A file where you have written down a whole bunch of codes. And what are there inside the codes? Some executable instructions. And this whole bunch of codes that contain executable instructions are stored in a file. It could be a .java file. It could be a .php file. It could be a whatever file, CPP file. So all these files are sitting there right somewhere inside your hard disk. And that is a program. But now we go to process. When we want to convert this program, as you say, the program which is running is called process. I take it from there. As we want to convert this process, this program into a process, we run it. Now, this word running is a very common word that we use most of the time, but it can be technically confusing. Because when we go inside this chapter, we will see that starting a process, that means a program file just starting up. You have just double clicked on it, double clicked on the icon to start up the program, start up the process. Doesn't necessarily mean it is running. A process in modern computers, when it is on RAM, this is where the core difference between process and program comes into play. When a program, those were like bunch of codes sitting inside your hard disk, have now been loaded on the RAM for execution. At that very moment, it becomes a process. Why I say that? Because while it is on RAM, it's not running all the time. It may have been blocked temporarily. Maybe it is standing in the ready queue, not yet running. So try to understand from a technical point of view. Let me summarize it, sum it up. The first program is a stored file. And as I use the word stored, you understand that we store it in the hard disk, and hard disk is a secondary memory, not a primary memory, a storage. And what does it contain? It contains a bunch of codes. It contains codes or executable instructions. That's what you do. And what is inside those executable instructions? A bunch of algorithm. I'm sure you're familiar with this word, algorithm. Right? Computer science is all about algorithm. We survive on this planet by following our own algorithms. Right? So that's what you have, executable instructions. Now, when you double click on that icon or you want to start up that program or to work with that program, the first thing you do is to convert it into a process. So process is program on RAM. I'd rather go that way to stay safe, to stay away from that word, that controversial, ambiguous word called running. While on RAM, this is a new thing that you are going to learn there. While on RAM, those codes be either one, running, that is executing, two, waiting in ready state, three, blocked. They are still on RAM, but still on RAM. So what is executing and running then? Executing and running in modern computers, in multi-processing computers, it refers to a program on RAM currently executing on CPU. That is running. Because remember, our computers at the moment are multi-programming computers. A program on RAM currently executing on CPU. That's what we call running. But as I said, in a casual way, we always say the things like, as you said, that we say the program which is running is a process. Okay. But now, when we go deep inside this chapter, we will find out that that may not be a technically perfect definition. Because if you want to be technically perfect, you should try to avoid the ambiguous word running. Because running is just one of the three states, the three major states a process can have. There's still process, a blocked process, a ready process, and a running process. We still call them process because they are on RAM. And then comes another state, terminated. When you terminate them, that means you offload them or you take them down and put them back in the stored file where it was stored. And this is true for any software, whether application software or operating system. And that's why every morning when you start up your computer, what do you see? You press the button, the power button, and you have to wait. Something happens. Okay? That's something that we call booting. Your computer boots up. Finally, towards the end of this booting period, you see your operating system, Windows, getting loaded. Now the question is, the Windows, where was it? When your computer was shut down, where was it? Yes, it was still there as a bunch of stored program files inside your hard disk. On the C drive or D drive, wherever you have installed that operating system. But then, when you start loading it, in all the times we used to see that message, Windows loading, please wait. But now, of course, Microsoft doesn't want to show you that message. They want to look at a beautiful picture. And behind the scene, it's the same old thing happening. So they're getting loaded on RAM. The very first thing that happens is those program files are transferred to RAM. And once they're RAM, because CPU can only read from the RAM. So anyway, we are nearing the end of this, and this is just an open, lightweight class. And as I say, we will start talking about all these things in a more methodical way from the next class on Wednesday. But these are some of the things, very interesting. So now you understand why I said to one of you when you asked me the question that you should take note as you listen to my lecture, as you look at the slides. Today I'm not showing you any slides, of course, but you'll be seeing the slides. Take note from them. Because later, when you go back to watch some external videos or look at some slides or read from the book, these little bits and pieces of knowledge that you have gathered by taking note from this lecture will help you to reconstruct the whole. So that is that very, very. You can easily reconstruct all the things. So it's a beautiful concept. Okay. All right. So we'll take a break here. And if you have still questions, feel free to ask me or send me an email. And for this class, and we'll go to taking your attendance because it does take a little bit of a time. And you can see right here. So I'm on the attendance page. We have 20 students here, and I'll just look at your screen. You can see it, and I'll call your names. Of course, my pronunciation is terrible, so just follow your screen. All right. Xuan Huang, Ji Kang,
Yes.
Wen Phuoc, Duc Huang,
Yes, I'm here.
Long Ha,
Yes.
Hu Huang,
Yes.
Tan Hung,
Yes.
Nop Phat,
Yes.
Din Min,
Yes, I'm here.
Quoc Huy,
Yes.
Huai An,
Yes.
Kim Thắc,
Yes, I'm here.
Nhật Min,
Yes.
Thian Phúc,
Yes.
Quang Huy,
Yes.
Min Kung,
Yes.
Duy Bao,
Yes.
Huay Min, Liêm Trúc,
Yes.
Quoc Hum.
Yes.
Thank you. It's a job done. Fine. Now, back to where we were. So we will continue with this kind of discussions, starting from the very basics in the introduction part. Basically, we will. I suggest that you read the first chapter or read the slides, because now that you're on LMS, you have a copy of the book, the ebook, and you also have the copy of those old slides and new slides. So, two things that we'll cover: zoo. Why do we call it a zoo, the operating system zoo? And also, we will talk about concept of operating system. And then we will talk about structure, of general structure again. of the operating system. These are part of the introduction that's coming up in the next lecture. Okay. A structure and some basic hardware. Basic hardware that you need to understand. Now, remember, hardware is the most important thing, as I said, and you already understand that if you take the OS out, your machine is dead. So basically, there you are. You have a machine, that's the hardware. On top of it, you put a layer of software, which is called system software, that is your operating system. And then this hardware suddenly becomes interactive and comes alive. And then on top of that, you install your apps or user level software, application software, and start interacting with the hardware. So your apps or the application level softwares are essentially facilitating the user level interaction. You're not supposed to interact with the operating system. So the operating system squeezed between on the upper side, the user level softwares, and the bottom, the hard between the user level softwares and the hardware is squeezed right in between. Is coordinating and controlling. Remember these two words. We'll find it in the next, in the first chapter, in introduction. In a concept, control and coordinate. These are the key words. Okay. That's the job of the operating system. And it is nothing but a bunch of codes because it's a software, but its primary job is to control and coordinate all interactions between application software on the one hand and the underlying hardware to generate an output from given inputs. Okay? All right. So that's all for today. If you still have any questions related to administrivia, feel free to get in touch. And in all the classes, I will not remind you, but remember, I will be taking your attendance randomly at random times. So you need to be there all the time, most of the time. And number two, the first thing after logging in, you should turn on your caption. That will help you. Because when I start giving the lecture, this online lecture, it's not always possible for me to go back and do it extremely slowly. And because of these technical things, maybe some of you may not understand the words that I've just spoken. So you can quickly look at your subtitle and you can read it from there. All right, so I leave you here and see you on Wednesday. All right. Bye.
Goodbye, sir.
Bye, teacher.
Bye, teacher.
Bye, teacher.